All right, so this is going to be a video on setting up our environment to use open source tools to do IC design. Um, it's just, rather than trying to figure out everything on your own, it's just better to clone my repository voltage divider. Okay, it should work. Then we just change into the voltage divider directory. If you're not aware, the star sign is a wildcard, so that should be voltage divider. And if we look inside of there, we can see some files, which we can actually look here. Okay, so we're not going to use necessarily everything on the first tutorial, but xschem is where we're going to do our SPICE simulations, right? This directory actually has some files in it already, almost like the solution, if you will, for some of the simulations. Okay. As part of another tutorial, all the files for the Magic tutorial is there from Magic. And then here is where we're going to keep our layout files, and we have the setup file for the Skywater 130. Right, so rather than trying to copy it over every time you have a project, you can just use that. Okay. Make sure we're in the right directory. So present working directory. And we're going to start the simulator environment xschem by going into xschem. Since there's only one x, we can just do cd x star. And here is a setup file that will be automatically read. And if you don't use this, your files might go somewhere else, let's just say. So if this is setting up things, and so right here, if this is set the way it is, it'll save everything in a directory called simulations. Since we haven't done anything yet, it doesn't exist. But if you don't do it that way, it might save your files somewhere else. So that's why it's kind of better to start here. So we just type it in. Alrighty. So when you do it this way, and I'm going to press the letter F to fully see everything, the Skywater 130 splash page comes up, and you can see all the devices that come with the PDK process design kit. And there's a lot of interesting demos and setups. For instance, I want to run a test on an inverter. I click on it, and I can type the letter E, and it brings me to this. Okay. Now we're going to do much more simpler things. But anyway, that splash page will always come up, and it actually has some useful stuff. So now we create a new tab, and we're going to create a voltage divider out of real devices. So we click on insert symbol, and then you should see these three libraries. The xschem library is the generic parts that you need to run a simulation. The 130 are all the specific parts to the Skywater 130, and then this directory, it will be your devices. So we want a real resistor for the chip, and those will be in this directory, Sky 130 FD PR. Okay, and then there are a lot of choices, and so has to be for later. It's very important, but we're going to choose resistance generic PO symbol, And it actually will tell you what the resistance will be based on the length and the width, the sheet resistivity. So we'll just press OK. Oh, my bad. What am I doing wrong? Oh, maybe create. Oh, I had zoomed out so far that I couldn't see the parts. So I'm just going to left click there and then the delete key, left click there and the delete key, left click there and the delete key. And now I'm just scrolling back and forth. So let's try that again. It was working and then it wasn't. So resistance generic PO. All right. And I'm just scrolling back and forward and I'll place that down. All right. Now I want to copy it. And there's certain ways to copy, you know, you can copy things from here, but really, if I left click on it and press the letter C, it copies it. All right. Now I can use the letter F to more center it, and then I'm using the middle mouse button to zoom in and out. So now I have two resistors, but I want to change the resistance. So you double left click, and the width I would like to be 0.33, and the length 10 microns. Okay, and it calculates it for you, 1461 ohms. And I want to make a voltage divider that divides in half. All right, so I'm going to just repeat. Okay, the units are in microns. All right, so now we have R1 and R2, but we don't have a way of, we need to connect it. And we're going to actually, rather than simulate it directly, we're going to make a cell, a hierarchical cell. So we need to have ports and labels. So labels are things that are more generic. So do the double dot here, just click once, and it raises the directory, and that's in the generic library. Click on devices, and then what I do, like I want a label, right? So I'm just going to type in label, and it's label pin is what I want. Okay, and I'm just gonna, no, that's not what I want. I want IO pin, simple. And I'm just gonna place it there, left click there, letter C. Okay, now I want to delete that. So I'm going to double click on the pin here, and out comes the value. So I'm going to call that VDD. The case is important, okay, in Linux, even though we're using Spice. Double click there, and we'll have our lower power supply. We need an output port, and so I'm going to search for output pin, and I just like to place things here. Okay, so now we need to wire it up. The wiring tool is a little bit different than other wiring tools, is that you hover over what you want to start, press the letter W, and then it'll draw, and then connect it to where you want to go, and left click it. All right, you don't, like other tools, you might keep using the wiring tool. You still have to hover, press W, end it with a left click. Start, And then I want to double click here and move it so that it's, looks good. All right, we have the final one where we hover over the pin here and that's like a solder dot, meaning they're all connected. All right, and we need to label it. Okay. And let's save it as voltage divider dot sch for schematic. All right. Great. Now, I said I wanted to make a hierarchical design, so we need a symbol. Well, it'll make the symbol for us. So make symbol from schematic, or you do the letter A. It asks you if you want to do it. You say yes, but it doesn't pop up. All right. So if we want to see it, create a new tab, and now we actually have devices in our directory. We have the schematic and the symbol, and you could edit it, right? You could conceive. Voltage divider is a long name, so that's why it's a long box, but you could manipulate that if you wanted. All right, now we have a lot of schematic to do, so we need to add a lot of parts. So why not add our own divider? So every time I zoom, I'm just pressing the letter F. All right. Now we have a lot of things to add here. So from the generic. All right. So we need a VDD symbol. A ground. Not quite sure what happened. And I'm just placing them randomly. The capacitance isn't really an IC capacitance, so I'm just using a generic one. All right. And we need a voltage source. So I'm just left clicking on things and then typing the letter M to move. I left click here, press C for copy, right, for which I like to have more than one. And what we can do with this is we copy that, which is effectively a net name, something weird there. Just gonna delete it. Something right here I don't like, so I'm left clicking on it, deleting it. So let's just try to draw it again. W. Okay. just zooming in a little bit. I'm having trouble. Okay. And that's just not right where I want it, so I'm just going to move it up a little bit. Okay, now. All right, that was getting annoying. So it doesn't allow you to keep every time you make a different segment, you have to press W again. Okay. Now we just have to do this. Okay, so now we've wired 3 volts to here. We have these common grounds. We have a capacitor here just for load. We want to name that, otherwise it'll just give us some random thing. And that's another symbol. So that's a label wire symbol. And it's out. So when we're plotting things, you know, it makes sense. So let's save it. Now what I like to do is I have the part, right? And now we're making a test bench for the part. So I just take the part name underscore TB. All right. Now, it's not quite ready to simulate yet. I'll leave it at that. And so, in fact, for this part, it's easier. It should be easier to go, let's say, to the solution. All right, so we're in voltage divider. Oh. I want to come to our parts and go up 1, voltage divider feedback here, and there's a template right there, which is pretty much what we were working on. And you need these setup files for it to work. So you just left click, copy, and paste it. Left click, press the letter C. I think if you keep it selected, it won't let you paste. So copy. There we go. And then just to make sure, we'll just save it. Now, I'm going to double click here. This says our simulation corner. There's statistics, and things can be thinner or faster. And TT is there's 2 devices, N transistors and P transistors, and TT means typical. All right. So you have to put that there, or won't know what to use. All right. Then the models. This is what loads in the models so that it knows what to simulate. And then here tells us what to simulate. So the name stimuli, that's that. The simulator will be ngSpice. And then here's the control. You have value, control, and we're going to do a transient, and we're going to plot these two things, and then save everything. All right. So now this is saved in what I would call xschem format, but the Spice simulators can't work with that. So you click netlist, and since it's a small circuit, it works right away. And if you want to see what that is, just come into voltage divider, xschem. Now it's created this directory, and you can see the Spice file. And if you double click on it, this is the text file that will control the simulation. Okay. So then we've net listed it, and now we're going to simulate it. And you know, it's just a DC value. You can see out was 1.5 and input was 3, so it's dividing by 2. That makes sense. And then here's a plot of that. Now nothing is really changing in time, but you can save this into Python and manipulate it. You can make pictures of it and grab it. So that's how to simulate a voltage divider with the xschem platform. All right. And the other thing we did is we made our own part. So if I click on that and press E, there's our part. And then something to open most recent. There we go. So here's the thing, just so you know, right? Let's say I want to use this again. I just press C and V and paste it. And now I have another voltage divider circuit. But if I descend edit into here, it's the same thing. So if I make an edit here, it makes it everywhere. All right. The other thing is if I fully test my voltage divider and it's working, and then I start hooking it up to something else, it's really only the addition of the something else where the problem can be. Okay. So there's a lot more to it, but you know, we have a voltage divider, one of the fundamental devices. So what's next is to use magic to create a file that has the physical description of what, you know, we're actually making. You know, what if you looked under a microscope, what would you see? Okay. So that's the end of this video.